On this slide, we'll delve into the realm of wireless attacks, a crucial component in our CompTIA PenTest plus PT0-003 certification course. Wireless attacks are a significant aspect of penetration testing, and it's essential to understand both their mechanics and implications to effectively assess the security posture of an organization. By performing wireless attacks, penetration testers can uncover vulnerabilities in wireless infrastructures that could be exploited by malicious actors. Understanding the nature of these attacks not only helps in identifying potential security gaps, but also guides the remediation and hardening of wireless defenses. In this segment, we will explore various wireless attack techniques, providing you the knowledge and tools needed to execute these methods in controlled, ethical scenarios. Now, let's move on to the next slide where we'll discuss war driving, a specific technique for discovering wireless networks. We'll cover its definition, impact, various techniques, and tools such as Wiggle.net, Insider, and how to use GPSD and Kismet effectively in war driving. Now that we have an understanding of wireless attacks in general, let's explore a specific type of wireless attack known as war driving. War driving involves driving around a specific area with the intent of discovering wireless networks. This technique is used to map the wireless networks available, which can later be targeted for unauthorized access or testing purposes. The impact of war driving mainly revolves around identifying poorly secured networks, which can be exploited later. A common method for performing war driving involves using tools like Wiggle.net and Insider. Wiggle.net is an online database of wireless networks where users can upload their findings. Insider is a software tool that helps in mapping and analyzing wireless networks. Additionally, tools like GPSD-D5-DevTUSB0 and Kismet can be employed for more detailed war driving endeavors. GPSD can be used to log GPS coordinates while driving, and Kismet is a powerful wireless network detector and intrusion detection system. Understanding the techniques and tools involved in war driving is essential for penetration testers, as it lays the foundation for more complex wireless attacks. Next, we'll be moving on to the evil twin attack, another significant wireless attack method. In the previous slide, we delved into the topic of war driving, covering its definition and impact, discussing various techniques, and exploring practical examples using tools like Wiggle.net, Insider, GPSD, and Kismet. Now, let's move on to the concept of evil twin attack. An evil twin attack involves creating a counterfeit access point that mimics a legitimate one to trick users into connecting to it. This allows the attacker to intercept, monitor, and potentially alter communications. The impact of an evil twin attack can be substantial, leading to unauthorized access to sensitive information such as login credentials, financial data, and private messages. To execute an evil twin attack, one typically sets up a rogue access point with the same SSID as the target network. Common tools used for this purpose include Wi-Fi Pumpkin, which provides an interface for creating and managing the fake access point. Here's a straightforward example. Using Wi-Fi Pumpkin, you can establish an evil twin access point with the following command: shell Wi-Fi Pumpkin. Once activated, users attempting to connect to the legitimate network may be redirected to your rogue access point, enabling you to capture their data. In the next slide, we'll discuss signal jamming, its definition and impact, techniques for performing it, and practical examples using tools like Aircrack-NG for deauthentication and jamming. On this slide, we're going to explore signal jamming, a crucial topic when it comes to understanding wireless security threats. So what exactly is signal jamming? Signal jamming is an attack that disrupts the communication between devices by overwhelming the network with interference or noise. This can effectively take down Wi-Fi networks, resulting in denial of service for legitimate users. The impact of such attacks can be significant, as it can lead to loss of connectivity for a wide array of devices, from smartphones to important IoT systems. Now, let's talk about some techniques for performing signal jamming. There are several methods, but one common approach involves sending continuous deauthentication frames to disconnect legitimate devices from the access point. This causes a persistent disruption of services. For example, a practical method for carrying out such attacks uses the Aircrack-NG suite. Specifically, the Airplay-NG tool can be employed for deauthentication and jamming. The command provided here demonstrates how to use Aircrack-NG for this purpose. Shell Aircrack-NG client Mac double anro. In this command, -0 tells the tool to send deauthentication frames indefinitely. .app MAC specifies the MAC address of the target access point. MAC client MAC specifies the MAC address of the client you want to target. WLAN0 is the network interface used for the attack. By using such tools, signal jamming can disrupt normal operations, highlighting the importance of securing wireless networks against such threats. In our next slide, we'll dive into protocol fuzzing, another important technique where we'll scrutinize the vulnerabilities of wireless protocols through deliberate manipulation. Stay tuned. Now that we have a solid understanding of signal jamming and its practical applications using Aircrack-NG, let's move on to another crucial topic: protocol fuzzing. Protocol fuzzing is a technique used to test the robustness and security of wireless communication protocols by sending malformed or unexpected inputs. The primary goal is to identify vulnerabilities that can be exploited to disrupt or take control of the communication process. The impact of protocol fuzzing can be significant, potentially revealing critical weaknesses in wireless network protocols. When performing protocol fuzzing, various techniques can be applied. One powerful tool for this purpose is Scapy, a Python-based program that enables us to craft and transmit custom packets. For instance, Scapy can be used to fuzz 802.11 frames, such as beacon frames, to test how network devices handle these unexpected inputs. Here's an example of how you can use Scapy for protocol fuzzing. Python from scapy.all import star fuzz.11.11 beacon. In this example, we use the fuzz function from Scapy to generate and send random 802.11 beacon frames. This can help identify how different devices respond to various malformed packets and can uncover potential security flaws. In the next part of this course, we will delve into packet crafting. We'll explore the definition and impact of packet crafting and learn techniques for creating and injecting custom packets into wireless networks. We'll continue using Scapy for practical examples, crafting our own packets to understand this technique better. So stay tuned as we dive deeper into the world of wireless security with packet crafting on the next slide. In the previous slide, we discussed protocol fuzzing, which involves testing for vulnerabilities in wireless protocols by injecting malformed or unexpected data and observing the system's response. We also explored how to use Scapy for this purpose, showcasing a basic fuzzing example with 802.11 beacon frames. Now let's move on to packet crafting. Packet crafting is the process of creating and injecting custom packets into a network. This technique allows penetration testers and researchers to simulate various network protocols and interactions, providing a powerful tool for security testing and analysis. For instance, in Scapy, we can build custom packets by defining each layer of the protocol stack manually. Here's a simple example. Python from scapy.all import create a custom packet with radio tap and .11 layers. pk equals radio tap .11 ff adder 2 equals 022 thief. Inject the custom packet into the network. Send pkt iface equals dualan 0. In this example, we construct a packet with a radio tap header followed by a 802.11 management frame, setting the destination and source MAC addresses. The sendp function is then used to transmit the packet over the specified wireless interface. Packet crafting can be useful for a variety of purposes, including testing the robustness of network protocols, simulating specific traffic patterns, and performing targeted attacks. Next, we'll examine deauthentication attacks, covering their definition, impact, and practical execution using tools like Aircrack-NG. On this slide, we're diving into the topic of deauthentication attacks. Deauthentication is a type of denial-of-service attack that targets Wi-Fi networks. The attacker sends forged deauthentication frames to the wireless access point or client, which causes one or more clients to disconnect from the access point. The impact of deauthentication attacks can be quite disruptive. They can be used to kick clients off a network temporarily, which could interrupt communications or cause difficulties in reconnecting. More maliciously, deauthentication attacks can be employed as part of a strategy to capture information during the reconnection process. There are several techniques for performing deauthentication attacks, and one of the most commonly used tools is Aircrack-NG, a component of the Aircrack-NG suite. Aircrack-NG can be used to send deauthentication frames to specific clients or broadcast them to disconnect all clients connected to a particular access point. Here is an example of how you would use Aircrack-NG to perform a deauthentication attack. Aircrack-NG Deauth100 NIDA A MAC DILN 0. In this command, -Deauth specifies that 100 deauthentication packets should be sent out. -A designates the MAC address of the target access point, and WLAN 0 is the wireless interface used for the attack. In our next slide, we'll be covering captive portal attacks, where we'll discuss what they are, their impact, and how they can be both implemented and bypassed. We'll also explore a practical example using Wi-Fi Pumpkin. All right, let's move on to slide 8, which focuses on captive portal attacks. Firstly, let's define what a captive portal attack is. A captive portal is a web page that users are automatically redirected to when they connect to a Wi-Fi network. Typically, this page requires some form of validation before granting access to the internet. The impact of a captive portal attack can be significant. Attackers can set up phony captive portals to capture sensitive information, such as usernames, passwords, and other personal details as users try to log in. This method of attack can also be used for phishing or spreading malware. Now, let's discuss some techniques for both setting up and bypassing these portals. To set up a captive portal, tools like Wi-Fi Pumpkin can be used. This tool makes it relatively straightforward to create a phishing page that looks legitimate to unsuspecting users. For instance, you can start a captive portal using the following Wi-Fi Pumpkin command: Wi-Fi Pumpkin-start captive portal. On the other hand, bypassing a captive portal can vary in complexity depending on the security measures in place. Techniques such as MAC address spoofing or DNS tunneling can sometimes be effective, but the specifics would require a deeper dive into network security principles. In our next slide, slide 9, we'll dive into WPS PIN attacks, their definition, impact, and techniques, including an example of using Reaver to perform such an attack. On this slide, we're diving into the world of WPS PIN attacks. The Wi-Fi Protected Setup WPS is a network security standard that allows easy connection of devices to a wireless network. However, one major vulnerability is the WPS PIN attack. A WPS PIN attack exploits the 8-digit PIN used in WPS to authenticate devices. This type of attack can be devastating because it allows the attacker to access the network without needing the actual password. The primary tool used for WPS PIN attacks is Reaver, an open-source tool designed to brute force the WPS PIN on wireless routers. Here's a common approach to performing a WPS PIN attack. 1. First, you'll start by identifying the network and its access point MAC address, APMAC. 2. Then you can execute the attack using the Reaver command, Reaver-ILAN0-B APMAC-VV. In this command, -ILAN0 specifies the wireless interface and -B APMAC indicates the BSS ID of the target access point. The VVV option enables verbose mode, providing more detailed output during the attack process. Remember, exploiting vulnerabilities like this without permission is illegal and unethical. However, understanding how these attacks work can help you better secure your own networks. In the next slide, we'll explore the Web Proxy Auto Discovery Protocol and how attackers can exploit its vulnerabilities using tools like Responder. Let's move on. On this slide, we delve into WPAD, or Web Proxy Auto Discovery Protocol. WPAD is a method used by clients to locate the URL of a configuration file using DHCP and/or DNS discovery methods. This protocol is particularly significant because of its potential vulnerabilities, which can be exploited if not properly secured. We will cover key techniques attackers use to exploit these vulnerabilities. One common method is using the Responder tool, which is a powerful suite for network poisoning attacks. With Responder, an attacker can listen to LLMNR, Link Local Multicast Name Resolution, and NetBIOS Name Service on a network, capturing hash values and potentially gaining unauthorized access. Here's an example of a basic command to perform a WPAD attack using Responder. Responder add-WPAD. In this command, the -I flag specifies the network interface, while the WW-R and MySF flags enable WPAD rogue proxy responses, analyze NTLM hashes, and perform fingerprinting, respectively. Understanding and mitigating these types of vulnerabilities is crucial in protecting network security. On the next slide, we'll be discussing Wi-Fi Pumpkin, a versatile tool used in wireless network attacks, particularly for setting up evil twin attacks. Stay tuned as we explore its features and examples. Wi-Fi Pumpkin is a powerful tool used for wireless security auditing and pen testing. In this module, we'll delve into how Wi-Fi Pumpkin can be used in wireless attacks. First, let's go over what Wi-Fi Pumpkin is. It's an all-in-one software for Wi-Fi security analysis, which allows you to create rogue access points to conduct man-in-the-middle attacks. This tool can be incredibly useful for setting up various types of wireless attacks, including phishing, sniffing, and more. Specifically, we'll focus on techniques for using Wi-Fi Pumpkin in these wireless attacks. One popular use case is the evil twin attack, where an attacker sets up a rogue AP that mimics a legitimate one to trick users into connecting to it. This allows the attacker to intercept sensitive information. To set up Wi-Fi Pumpkin for an evil twin attack, you would typically use the following command: bash Wi-Fi Pumpkin. From here, you could configure your rogue access point with the same SSID as the legitimate AP and initiate the attack. All right, let's move on to the next slide, where we'll explore Aircrack-NG, another essential tool in the arsenal of wireless security. Let's move on to the next tool in our exploration of wireless penetration testing. Here, on slide 12, we're looking at Aircrack-NG. Aircrack-NG is a comprehensive suite of tools designed to assess the security of wireless networks. It is highly versatile and includes utilities for monitoring, attacking, testing, and cracking Wi-Fi networks. First, let's go over some techniques for using Aircrack-NG in wireless attacks. The suite comprises several command line tools, but for today's discussion, we'll focus on two of them: AeroDump-NG and Aircrack-NG. AeroDump-NG is used for packet capturing, which involves listening to and capturing data packets from Wi-Fi networks. This can be especially useful for gathering data to later feed into Aircrack-NG for the actual key cracking process. You would typically run a command like AeroDump-NG WLAN0, where WLAN0 is the interface name. Aircrack-NG is the tool used for cracking WEP and WPA-PSK keys. A common attack involves capturing the WPA2 handshake and then attempting to crack it using a word list. For instance, the command Aircrack-NG wwordlist.txt-b8mac capturefile.cap would attempt to crack the WPA2 handshake in the file capturefile.cap using the word list provided in wordlist.txt. To give a concrete example, you would 1. Use AeroDump-NG to capture traffic and identify target Wi-Fi networks. 2. Once you have captured the WPA2 handshake, you would use Aircrack-NG with a word list to attempt to crack the encryption. Next, we'll delve into Wiggle.net and explore how it can be leveraged in war driving applications. Now that we've covered how to use Aircrack-NG for capturing and cracking WPA2 handshakes, let's move on to another invaluable tool in our wireless assessment toolkit: Wiggle.net. Wiggle.net is an open-source platform that aggregates Wi-Fi network data for the purpose of research and analytics. It combines the efforts of various users who contribute data on Wi-Fi networks they encounter while war driving. In the context of war driving, Wiggle.net provides an interactive map that can be used to search for Wi-Fi networks and visualize their geographical distribution. This can be particularly useful when planning penetration testing or understanding the wireless landscape of a target area. For example, you can search for specific SSIDs or filter networks based on various parameters like encryption type or signal strength. Once located, the data can be used to map out the network's location and other relevant details. The next slide will introduce another powerful tool, Insider. We will explore how Insider can help us scan and analyze Wi-Fi networks to gather deeper insights. Now that we've covered Wiggle.net, let's move on to another essential tool in the wireless network analysis toolkit, Insider. Insider is a popular tool used by professionals and hobbyists alike for scanning and analyzing Wi-Fi networks. It provides a detailed overview of available networks, including information such as SSID, signal strength, channel, and security type. Understanding the capabilities of Insider can significantly enhance your ability to assess and map out wireless environments. For instance, during a wireless attack or penetration test, Insider can help identify weak points in network security by revealing configuration details and potential interference. For example, you might use Insider to scan an office environment. It would display a list of all detected networks, allowing you to spot overlapping channels or identify unsecured networks that could be potential entry points. In the next slide, we'll delve into Kismet, another powerful tool for wireless network analysis with its own unique features and capabilities. Now that we have covered Insider, let's move on to another essential tool in the arsenal of wireless network analysis, Kismet. On this slide, we'll first provide an overview of Kismet. Kismet is an open-source wireless network and device detector, sniffer, and intrusion detection system. It captures Wi-Fi traffic across multiple channels and detects hidden networks and devices. Next, we'll delve into techniques for using Kismet in wireless attacks. This includes its use in passive network monitoring, discovering hidden SSIDs, and capturing unencrypted traffic for further analysis. These capabilities are incredibly valuable when trying to understand the layout of a wireless environment or when gathering information for a penetration test. To illustrate its practical application, we'll walk through an example of running Kismet to capture Wi-Fi traffic. Using Kismet, you can monitor the airwaves for all detectable wireless networks and devices, logging critical information like MAC addresses, signal strength, and network types. This data is useful for mapping the network or identifying potential security weaknesses. In the next slide, we will wrap up our discussion with a conclusion and review of wireless attack techniques and tools. We'll summarize what we have learned about Insider and Kismet, emphasize the importance of mastering these tools for successful penetration testing, and provide suggestions for further learning and next steps. Let's now summarize and solidify our knowledge on wireless attack techniques and tools in the upcoming conclusion and review section. Slide 16, Conclusion and Review. In this final segment, we'll summarize the key wireless attack techniques and tools we've discussed in this course. We've covered various methods from passive eavesdropping to active attacks and explored specific tools like Kismet. Practicing and mastering these techniques is crucial for any penetration tester aiming to conduct thorough and effective security assessments. The knowledge and skills you've gained here will serve as a foundation for more advanced penetration testing efforts. As for next steps, I highly recommend continuing your education in cybersecurity, perhaps focusing on advanced wireless security practices, engaging in hands-on labs, or obtaining certifications that can further validate your expertise. Thank you, and best of luck with your ongoing learning and professional journey in penetration testing.